This video is for lesson 7-3 about perpendicular lines. Learning goals are to develop some theorems to show that lines are perpendicular and to determine whether lines are perpendicular. A second customer of Patios by Madeline has hired the company to build a patio with rows of bricks that are perpendicular to the walkway as shown to the right. So here we have the walkway kind of coming in at this angle, and notice this time the bricks are in a perpendicular arrangement to that walkway. Matt is planning the design for this patio. So far, he has extended a line along the walkway and labeled points X and Y to mark stakes at the edge of the patio. He has also drawn point W to mark another stake at the edge of the patio, as shown below. So here's the drawing of that patio, but without the outline of the bricks shown. And there is a line that's an extension of the walkway. It's line YX. Question 1. Use a protractor to draw the line perpendicular to line XY that passes through W and label the point of intersection point Z. I have done that in purple. So here was point W. Here is the line XY that I want to draw perpendicular to, and that's the purple line creating a right angle. I labeled that point Z. Number 2, use your protractor and your knowledge of parallel lines to draw a line across the patio parallel to line WZ. Explain how you know the lines are parallel. So it doesn't say where, but somewhere across the patio, we want to draw another line that's parallel to the purple line WZ. Something like this, where this is perpendicular to XY, and these two are parallel. In geometry, there's a way to show lines are parallel. You kind of color in an arrow symbol on the line. These matching arrow symbols indicate that those two lines are parallel to each other. How do I know that they're parallel? Because that angle's 90 and that angle's 90, and those are corresponding angles. When corresponding angles are congruent, the lines are parallel. Number 3, describe the relationship between that newly drawn line and line XY. The brown line and line XY meet at a right angle. They are perpendicular. So that was my answer to number 3. Number 4, Matt reasons that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. Show that Matt's conjecture is true and include a diagram. So I've drawn some parallel lines because this talks about parallel lines. I made a transversal that was perpendicular to one of those lines. And how do I know that that's going to be also perpendicular to the other line? My reasoning would go something like this. Because the measure of angle 1 is 90 degrees, and because it is congruent to angle 2, their corresponding angles on parallel lines, that's how I know that it's also going to be a 90 degree here, and they are perpendicular. Now, number 5, Matt draws segment AB on his design of the patio so that line XY is the perpendicular bisector of segment AB. Line XY intersects segment AB at point M. List 3 conclusions you can draw. First thing, I'm going to go back to that drawing, and I'm going to draw this right here. Segment AB so that XY is its perpendicular bisector. So XY was this original line coming across here, and I want to draw segment AB so that that line is its perpendicular bisector. So something like this. If I had a segment go across here like this, and again, remember I want to call this A and B. And if line XY is perpendicular and bisects segment AB, meaning I want that to turn out to be congruent to that, then that is a picture of XY being a perpendicular bisector. Now, what 3 things could we conclude? Well, we can conclude that this is a right angle. We can conclude that this is congruent to this piece. And we can conclude that this point is the midpoint of segment AB. And so those three conclusions are written here. The line and segment AB form right angles. Point M is the midpoint of segment AB, and segment AM is congruent to segment MB. Here are some check your understanding questions, so I'll pause the video.